computer system is byte addressable, right? And uses 32-bit addresses to access any byte in its memory. What is the maximum usable size of its memory in gigabytes? Show all your workings clearly. I'll get back to this question. I will work out in the board. Now remember 32-bit addresses, and they are telling byte addressable. The word byte addressable is given in this question. Byte addressable කියන වචනේ දීලා තියෙනවා. අපි ගත්තොත් එහෙම now I told if you have 1 bit, 2 addresses, that means you can have 2 addresses mean 2 byte. If it is byte addressable, then මේ question එකේ කියන්නේ byte addressable. Byte addressable කියන්නේ එක address එක එක byte එකක් තියෙනවා. So this is if you have 1 bit, 2 bytes. That if you have two bits, that means you can have 4 addresses. 4 addresses can 4 byte. Bit 3 නම් 8 addresses, 8 byte. Bit 4 නම් 16 addresses, 16 byte. ඔන්න ඔය කතාව දැන් අපිට මතකයි. Now in this question, what they are telling, they are using 32 bit. එහෙනම් 32 bit තියෙනවා නම් මම මේක erase this part. දැන් අපේ theory එක දාන්න. 32 bit තියෙනවා නම් how many addresses we can create? එහෙනම් number of bits equal 32, number of addresses equal 2 to the power 32. දැන් අපි කිව්වා bit ගාන power එකක් විතර දුන්නාම number of addresses we can create. So here number of addresses equal 2 to the power 32. Because we have 32 bits, අපිට bits දෙකක් තියෙනවා. එහෙනම් number of addresses අපිට හදන්න පුළුවන් addresses ගාන 2 to the power 32. And in this question they have mentioned byte addressable. ඒ කියන්නේ එක address එකක තියෙන එක byte එකක්. So I will take memory space in bytes. Memory space in bytes. එහෙමනම් අපිට ගන්න පුළුවන් 2 to the power 32 bytes. 2 to the power 32 bytes. අයි මම කිව්වා number of addresses ගන්න 2 to the power 32. එහෙමනම් memory ඒ කියන්නේ address ගන්නට සමාන bytes ගන්නක් තියෙනවා because in the question they have given byte addressable කියලා. එහෙනම් අපේ size එක 2 to the power 32 bytes. But in that question they are asking in gigabyte. So I'll take here 2 to the power 32 bytes. How to convert it to gigabyte? We have to divide. එහෙනම් bytes kilobyte කරන්න අපි 1024 වලින් divide කරා. 1024 means 2 to the power 10. එහෙනම් megabyte කරන්න ආපහු 1024 වලින් I have to divide, so I'm taking 2 to the power 10 again. Again to convert it to gigabyte, again I have to divide by 1024, that means 2 to the power 10. So all together මට මොකක්ද answer එක වෙන්නේ 2 to the power 32 divided by 2 to the power 30. So you know when you are dividing is subtracting. බලයක් බෙදද්දී subtract අඩු වෙනවා. එහෙනම් මට බෙදලා ගන්න පුළුවන් 2 to the power 2. 32 ගෙන් 30 ගියහම 2යි. 2 to the power 2 gigabyte. ඒ කියන්නේ අපිට ඕනනම් ගන්න පුළුවන් 4 gigabyte. 4 gigabyte. This is the way you have to calculate that, right? So can you write down that question? Write down this question. Part A, write down. If a computer system is, I think this is from 2013 or 2014, I extracted this one. I can't remember the exact year. If a computer system is byte addressable and you can write somewhere in the tutor, somewhere in the book. If a computer system is byte addressable and uses 32-bit addresses, 32-bit addresses to access any byte in its memory, to access any bytes in its memory, what is the maximum usable size of its memory? What is the maximum usable size of its memory? In gigabyte. Show all your workings clearly. Show all your workings clearly. Okay, so this is the way of doing that. Take this down. When you, that showing all this working means you have to mention all this stuff, otherwise you don't get the full marks. Right? එහෙනම් මෙතනින් අපිට number of bits ගන්න ලියන්න. Number of addresses means 2 to the power 32 කියලා ලියන්න. Memory space in bytes because it's bytes addressable 2 to the power 32 bytes කියලා ලියන්න. ඊළඟට මේ උඩට ගිහිල්ලා මේක bytes කිලෝ gigabyte කරන විදිය කියලා මේක 4GB කියන එක හැදෙන හැටි ලියන්න. Take it down quickly. මේක දාගන්න ඉක්මනට. Okay, we'll go to the another question. We'll write down this question. The memory of computer system is the memory of write down this question. The memory of computer system is byte addressable and byte addressable and has a maximum usable size of 4 GB. What is the minimum width of its address? What is the minimum width of its address bus? What is the minimum width of its address bus? In bits. Show all your workings clearly. Show all your workings clearly. Right? So we'll see how to do this one. Now they are telling we have the memory 4 GB. Now this is the same question other way round. අනිත් පැත්තට තමයි මේ question එක ආදී. ඒගොල්ලෝ මුලින්ම දීලා තියෙනවා size. Size is given. Right? So we'll see how to do that. You have 4 GB. So how many first we have to convert it to byte. So 4 GB I have to convert, I have to multiply by 1024. If I multiply by 1024, that is gigabyte become megabyte, again 1024, kilobyte, again 1024 byte. So that means I can take 4 into 2 to the power 30. When you convert 4 into 2 to the power 30, you get, this is in bytes. So I can tell altogether 4 means 2 to the power 2. So altogether this is 2 to the power 2 plus 2 to the power 30. Altogether 2 to the power 32 bytes. 2 to the power 32 bytes in the memory, right? So this is number of bytes that you can take from the 4 gigabyte. Then we'll see how many bits you need to address this space. Now after finding this, 2 to the power 32 bytes are there. So out of that, now this 32 means number of bits. Now we discussed in the very first time. So number of bits can represent with the 2 to the power as a power to get the size of the memory. Size එක හොයන්න මේ විදිහට use කරා. So this is 2 to the power 32 bytes. This 32 means the number of bits that you can use to get this 4 GB. So in this question, you can mention number of bits needs equal 32. So this is the answer for the question. Okay, take this down also. Take it down quickly. Okay, we'll go to another question. Okay, in this question, what they are telling, we'll see. A 32-bit computer has a byte addressable main memory. Byte addressable main memory. No need to write this one, I will just explain. A 32-bit computer has a byte addressable main memory. The computer uses 32-bit addresses to access any byte in its memory. It is observed that a maximum of 4 GB memory is available for a purpose even after the main memory is replaced by an 8 GB memory. Explain with all the calculation why this happened. Why this happened. So now in this question they are telling, we have replaced 4 GB with 8 GB RAM. 4 GB with 8 GB RAM, right? So and they are telling the computer uses 32-bit addresses. 32-bit addresses. That means now we have discussed earlier one. If you have 32-bit maximum size එක අපිට access කරන්න පුළුවන් maximum size එක 4 GB. So this is the thing we discussed earlier නේද අපි කලින් කතා කරා මේම 32-bit නම් අපිට 4 GB තමයි maximum address එකෙන් access කරන්න පුළුවන් memory එක. Even you replace මේක replace කරොත් 4 GB එක 8 GB කියලා RAM එක අපි replace කරනවා. But nothing will happen right? Because we can access only 32 bit. With the 32 bit we can access maximum size එක කියලා 4 GB. Even we replace 8 GB ධර්මයට වැඩක් තියනවද? නෑ. ඒකට අපිට කියන්න පුළුවන් we have only 32 bits for the address bus, so we can access the maximum size is 4 GB. Even you replace with 8 GB or more than that even, nothing will happen. That cannot be accessed. ඔන්න ඔය කතාව තමයි කියන්නේ. No need to do it again. දැන් අපි මේ කතාවම තමයි අපි හොයලා පෙන්නන්න ඕනේ with the 32 bit maximum size that you can access 4 GB කියලා පෙන්නන්න. ඊට පස්සේ කියන්න මේ 8 GB දුන්නට වැඩක් නැහැ because you can't access. You can access up to 4 GB only, right? Okay, we'll go to another question. එකක් පොඩ්ඩක් ලියාගමු. An embedded system write it down. An embedded system uses 16-bit wide address bus. 16-bit wide address bus to access its byte addressable main memory. In that question also they have mentioned byte addressable. They can address එක තියෙන පුළුවන් byte එකක් කියලා ඒගොල්ලෝ කියනවා. Byte addressable main memory. What is the maximum usable size in its? What is the maximum usable size of it? What is the maximum usable size of its main memory? Show your computations clearly. So they are telling we have 16 bits. 16 bit. We'll see how to do that. So we have 16 bit. දැන් අපි දන්නවා number of bit ගාන 2 to the power 16 කියපු ගමන් according to question they have given each address you can create a 1 byte. So I will write down like this. Number of bits equals 16, right? Then number of address that we can create 2 to the power 16. So memory space that can access. Now in the question they have mentioned byte addressable. Byte addressable කියලා දීලා තියෙනවා. 2 to the power 16 address ගන්නට සමාන bytes ගණනක් තියෙනවා. 2 to the power 16 bytes. So this is the answer, but මෙහෙම තියනට වඩා it's better if you can convert it to megabyte, gigabyte or whatever. So bytes අපි kilobyte ගන්න we have to divide by 1024. කියන්නේ 2 to the power 16, 1024 means what? 2 to the power 10. එහෙනම් මම බෙදනවා මේක. I'm getting 2 to the power 6 kilobyte. 2 to the power 6 means 64 kilobyte. So this is my answer. 64 kilobyte, right? So අපිට හැම වෙලේම ඔළුවේ තියාගන්න bits ගාන power එකක් විදිහට ගත්තාම addresses ගාන හොයාගන්න පුළුවන්. ඒගොල්ලෝ in the question they have to mention whether it's a byte addressable or kilobyte addressable, megabyte addressable, whatever it is. Right? ඒගොල්ලෝ දැන් මේ හැම question එකකම තිබුණේ byte addressable. ඒකේ නිසා number of addresses ගාන equal වෙනවා number of bytes ගාන. මේක බැරි වෙලා හරි if it is kilobyte addressable කියලා ඒගොල්ලෝ mention කරලා තිබ්බනම් we have to take 2 to the power 16 kilobyte. That is the only place you have to change, right? Then after that you have to convert it to this is 2 to the power 16 in bytes, kilobyte කරනවා මේක බෙදුවා. දැන් ලොකු ගානක් ආව නිසා අපි කලින් questions වල we divided to the power 30 වගේ බෙදලා gigabyte වලින් ගත්තා. So that's the same thing, right? So this type of question can come for the memory management thing. හරි අපි බලමු එහෙමනම් questions ටිකක්. Okay, these are the questions that has come from the unit 2 past paper question. I am launching the polling, so you can answer there. ඔයගොල්ලන්ට answer එක මේ mark කරන ගමන් මම එවන polling එකට questions පළවෙනි 10ට ඔයගොල්ලෝ mark කරන්න answers. එතකොට අපි ඒක discuss කරමු. I will send it to the WhatsApp group also. මම group එකකට මේ paper එක දාගන්න. එතකොට ඔයගොල්ලන්ට එතනත් බලන්න පුළුවන්. I am launching the polling. හරි ඔයගොල්ලන්ගේ screen එකේ question number 1 2 එක පෙන්නනවා ඇති. ඔයගොල්ලන්ට තියෙන පළවෙනි question එකට මොන answer එකද කියලා mark කරන එක විතරයි. Right? First 10 question කරලා we'll discuss, then we'll do other question like that. We'll go like that. We'll discuss this question. So most of you have answered. Check your answers. For the second first question, you all have put second answer. Second answer. We'll see. Who invented the analytical engine? So analytical engine actually, yes, invented by Charles Babbage. So second answer should come. That's correct, all of you. Then second question. You all have put fourth answer. We'll see which of the following technology using second generation. So check second generation use transistor. That is also correct. Then we go to third one. Third question. Some of you have put third answer. Some of you have put fifth answer. Which of they have given the following properties: density, capacity, security, cost, and access time. So they are asking which of the above are being used in the main properties of the classified different types of memory. When you are classifying the memory, when you are classifying the memory, we are considering about density. The density means how much data you can store. Capacity can density and capacity. The difference is capacity means the capacity, physical, logical capacity of that, but density means how much information is there. එතකොට පොඩි ඩිෆරන්ස් එකක් තියෙනවා මේ දෙකේ. අපි ඒකත් අපිට බලන්න වෙනවා when you are checking the properties of the memory. Security, we are not worrying about security. Memory එක මේව කරද්දී අපි security, we are not worrying about that. Cost we have to consider. Access time also we have to consider. So A, B, D, E should come. There is fifth answer should come. Some of you have put correct answer. Then we'll check fourth one. You have mentioned fourth and fifth answer. We'll see. Consider following memory: read-only memory, secondary storage, cache memory, flash memory, random access. Which of the above can be considered volatile? Volatile means when the power goes, everything inside the memory will be vanished. හැමදේම නැති වෙලා යනවා. එහෙනම් අපිට ROM එකේ නැති වෙලා යන්නේ නැහැ. Secondary storage කියන්නේ ඔය hard disk ඒවා නැති වෙලා යන්නෙත් නැහැ. But cache memory එකේ ඒවා නැති වෙලා යනවා. RAM එකේ flash memory කියන්නේ pen drive වගේ ඒවා නැති වෙන්නෙත් නැහැ. RAM එකේ ඒවා නැති වෙලා යනවා. So C and E should be fourth answer. Fourth answer. අපි බලමු fifth and sixth. We'll see what are the answers you have mentioned. Fifth එකට fourth එක ගහලා තියෙනවා, fifth එක ගහලා තියෙනවා ආයි. Yes. Consider following statement. Reading time from memory was assumed to be negligible. Utilization of hierarchical memory structure. Inability for foresee the limitation of the processor clock frequency. Which of the above prevent the technological advance beyond the von Neumann architecture? So we discussed what are the parts in von Neumann architecture. So in this they are asking which of the above prevent the technological advance beyond the von Neumann architecture. So after the beyond the von Neumann ඒකට පස්සේ අපේ මොනවද technological advancement වෙලා තියෙන්නේ prevent කරලා තියෙන්නේ reading time assumed to be negligible. That means ඒක නිකන් නොසලකා හරින්න පුළුවන් මට්ටමට ගන්න පුළුවන් reading time එක. ඒක හරි නේද? ඊට පස්සේ utilization of hierarchical memory structure. ඒක අපිට ගන්න බෑ von Neumann architecture එකේ තියෙනවා ඒක නේද? Inability to foresee the limitation of processor clock frequency. Processor එකේ frequency එක. That means the speed එක limitation එකක් අපිට ඒක කියන්න මෙච්චරයි කියලා limit කරන්න බෑ. Right? So we can take A and C, that is fifth answer you can take. Then we'll go to sixth one. Sixth one එකේ ඔයගොල්ලෝ ගන්න තියෙනවා first answer එක, third answer. Who is considered the first computer programmer? So first computer programmer is Ada Augusta Lovelace. This is the answer. Now these things I want to tell you. මේවා ගොඩක් රාට පොඩක් ඔළුවේ තියාගන්න ඕනේ මේ එක එක ඒවා හොයාගත්තා ඒ වගේ. So if it is not in the note, එක note එකේ නැත්තම් just write down somewhere or you have this paper with you. So remember those names and all this stuff. පොඩක් questions වල ඉතින් අහනකොට හරි අපිට ඒ ටික ඔළුවේ තියාගන්න මතක තියාගන්න try එකක් දෙන්න. එතකොට first computer programmer අපි කියනවා Ada Augusta. First programmer Ada Augusta. So we'll go to seventh one. Which of the following techno has been used in third generation? Third generation එකේ use කරේ මොනවද කියලා අහන්නේ? Integrated circuit, that is ICs. First one. Then we'll go to the 8, 9 and 10. The data in is read by using the laser technology. Laser technology, what is the data that's reading using laser technology? That is the CDs, DVDs and all this stuff. That is called compact disc. 8-1 is the third answer. 8-1 is third answer. Yeah, all of you have put the correct answer. Then question number 9. The component of that decodes the instruction. Decode karana instruction decode karana, I told you when we are talking about fetch, decode, execute cycle. අපි decode කරනවා කිව්වේ control unit. This is third answer. I think most of you have put the correct answer. Yes, it is there in the tube. 10th one. Which of the following data storage device provide the fastest random access? Fastest access එක අපි කියනවා less time නම් fast access. We discussed the memory hierarchy. The memory hierarchy, according to the memory hierarchy, make it in the cache memory registers are the having highest fastest access, but in the question they haven't mentioned those stuff. But RAM, all this stuff are coming, all this stuff are coming under main memory. So main memory එක තමයි වැඩිම access speed එකක් තියෙන්නේ. So 10th one, first answer should come. First answer should come. I think only one, yeah, has put the first answer. Who's that? How the පළවෙනි answer ගැහුවේ? පළවෙනි එක එක්කෙනෙක් මාක් කරලා තියෙනවා. Dihini, is that you? Okay, right. Okay, we'll go to the other questions. ඊළඟ questions ටිකට යමු අපි. I am sending the polling again. From question number 11 to 20. I have launched the polling. පටන් ගන්නකොට mark කරන්න. Question number 11 to 20. We'll start from question number 11. High-speed temporary storage, which is part of the microprocessor that hold an instruction during the execution. During the execution is called, that is called registers. Registers. So first one should be the answer. Most of you have put the first one. Now in the question they are telling part of microprocessor. Part of microprocessor means inside the CPU. So inside the CPU you have registers. Outside the CPU you have RAM. Those who have put the RAM, that's wrong, because they are telling inside the processor. Inside the processor ඇතුළේ තියෙන registers. නැත්නම් cache one, cache level 1 cache memory. So cache memory කියන එක මේක නෑනේ. නිසා registers we have to take. Then typically the cache memory is used to store the most frequently accessed data temporarily. So temporary data only can be accessed. 12th one. 4th one should be the answer. Most of you have put the 4th answer. 13. Babbage difference engine. Difference engine is based on, now that is difference engine is based on actually first one, that is mechanical technology. So first one, all of you have put the correct answer. Very good. Right. Okay, we go to the 14. Which of the following component located outside the micro? Now it is outside the microprocessor. Outside the microprocessor, you have RAM. RAM is outside the microprocessor. 14th one. So second one should be the answer. All of you have put, only one has put 4th answer. Why is that? There is registers inside the inside. This is inside. අතර ගහපු එක්කනේ වැරදි. ඒක registers ඇතුලේ තියෙන්නේ. processor එක ඇතුලේ. RAM එක outside the processor. processor එකෙන් එළියනේ RAM එක තියෙන්නේ. ඒතකොට RAM එක අපිට අයින් කරන්න පුළුවන්. We can upgrade them. So inside the processor we can't do anything. So second one should be the answer. 5th one. Which of the following one of the principal inventor of the electronic numerical integrator and computer, ENIAC. ENIAC is done by, now we'll see what are the answers you have put. Yes, you all have put the 5th answer, John Pressbreaker, 5th one. Correct. 16. Which of the following statement is correct with respect of the evolution of computing device? So when we consider about evolution of computer එක evolute වෙන්නේ කොහොමද? evolution එක උනේ කොහොමද කියන එක බලුවොත් එහෙම ඒක ENIAC was developed by using vacuum tube. So 4th one should be the answer. I think all of you have put the correct answer. 4th answer. Which of the following fastest access speed? Which one has faster access speed? So less time, high speed. That day we discussed. You all have put, most of you have put second answer. Yes, that's the correct one. Fastest access HTML memory. Then we'll go to 18 one. Charles Babbage is considered as father of computer by some people. That is because, why he is considered as father of computer? Because he introduced the concept input, processor and output. That 4th answer should be count. Most of you have put the 4th answer. Right? Then 19. The first generation computer based on. Answer for that. 19 you all, no, 2nd, 5th, yes. So first generation computer, that is in vacuum tubes. Right? So one student has made the mistake. These are theory. So you have to by heart this stuff. You have done those stuff, right? Then we'll go to 20th one. 20th one. 20th you all have put 4th. Yes. 20th, if you go to the 20th, random access memory modules are often compared by the capacity measured in blank and the speed measured in, they have given some words, right? So, so capacity measured in definitely gigabytes, and the speed usually measured in uh, megahertz. So third one should be the answer. Okay, we'll go to the from 21. We'll start from 21. I'm sharing again. Okay, we'll go to the question number 21. An application which require more space. Uh, okay, you will have submit answers. I will share the result also. Okay, first question we'll see. An application which require more memory space than the maximum memory space available in the primary memory of a computer is ready for execution. Which of the following is used by the operating system of that computer to satisfy this need? Now, if you try to run a program, now suppose your program is 2.5 GB, but you have 2 GB RAM. So how we take the that 0.5 and run the program? There's a mechanism. So that is called virtual memory. Virtual memory. So fourth answer should be the correct one. These things we'll be discussing in operating system. The separate unit is there. Unit 22. Which of the following is not typical use of random access memory of a personal computer? Keeping data for processing, holding instruction for operation, providing storage rating, keeping the BIOS program. BIOS program is keeping inside the ROM, not the RAM. Not a typical use. Fifth answer should come. Fifth one should be the answer. We'll go to third question, 23rd. Consider following statement in dynamic random access memory, DRAM, and static RAM, SRAM. Registers are made of DRAM. DRAM faster than SRAM. DRAM is more dense than SRAM. Now, when you take the registers are made from actually SRAM, not the DRAM. That's wrong. DRAM is faster than SRAM. That is also wrong. Then DRAM is more dense than SRAM. That is correct. So 23, third one should be the answer. Yeah, most of you have put the correct answer. We'll go to from 24 to 25 those stuff. Which of the one is statement true? The first generation computer was built by using transistor. That is wrong. The electronic numerical integrator ENIAC is second. No, that's also wrong. Ada Lovelace is inventor of the analytical. No, is the programmer, first programmer that we discussed during its first computer program. That's also wrong. That's Ada Lovelace. The first calculator device is declared to be abacus. Yes, that is the correct answer. 24. Fifth answer. Let's see your answers. Yeah, most of you have put the correct answer. Then 26, the content is stored in. is read by using the optical technology. Optical technology we discussed the previous question also. So optical that is done by the compact disc. 26 fourth answer should come. Now these are theory I am repeating. You have to by heart. 27. In modern computer, multiple levels of cache memory is used to optimize the performance. So among them, the level whatever the cache which is on. Okay. So what you have in the microprocessor, that is level 1 cache. Level 1 cache I told it is in the processor. Processor ඇතුළේ තියෙන level 1 කියන cache එක. එහෙනම් third answer. Most of you have put the correct answer. 28, we'll go to 28. Consider following statement about dynamic RAM, DRAM. Period refreshing, that is refreshing is correct. DRAMs are refreshing. Registers in the processor, no, that is I told earlier, it is SRAM. DRAM එකෙන් නෙමෙයි හදලා තියෙන එක වැරදි. Memory density of DRAM is higher than the static RAM. මේක හරියන A and C. Fourth answer should come. Then 29. Who proposed a stored program? Stored program concept එක කිව්වේ von Neumann. Von Neumann. Fifth answer should von Neumann. So ඒකත් එක්කෙනෙක් වරද්දලා දිනවා. එක්කෙනෙක් වරද්දලා දිනවා. So you have to by heart. මේවා පාඩම් කරගන්න වෙනවා මේ these things. Now you can understand these are the questions has come from the unit 2. කොහොම theory questions අහන්නේ ඒ නිසා හොඳට බලා ගන්න වෙනවා theory part එක. Then we go to 30th one. Which of following components is generally seen outside the center? එළියද මේ question එක I can remember මේකම අහලා තිබ්බ කලින් අවුරුද්දක. So you can understand same type of questions are asking. එහෙනම් එළිය තියෙන මොකද්ද? RAM එක. So that's the answer. 30th first answer. Right? So mama again we'll start from 31 to 37 you have. Again I am doing the polling. 1, 2, 3 like that. අර වගේම answer කරමු. First 31 question. Which of the following secondary storage device generally considers to provide the fastest access? Fastest access. Now this is related to secondary storage. Secondary storage වලින් fastest එක අපි දන්නවා අපේ computer එක ඇතුළේම තියෙන එක, that's called hard disk. Hard disk. Most of you have put the correct answer. 32. Which of the is usually used to boot up? Boot up කරන්න අපි කියන ROM එක. ROM is a firmware. So first answer. 33. Which of the following is the main use of complementary memory? That is CMOS memory. CMOS memory is a CMOS memory. You can have all these basic input-output systems. That BIOS programs are kept or powered by the CMOS. That is booting procedure. Fifth answer should come. Fifth answer should come. Most of you have put the correct answers. Yes. Then on the motherboard used to expand the functionality of a computer. 34. So you can now if you want to expand the RAM, you have to put a RAM card on the RAM slot. That is slot. The word slot should come. 34. Then we 35. Which of the following statement is correct? Correct is statement asking application software. What's the correct one? System software support data communication between peripheral devices. This is the correct one. 35. Third answer should come. So no, wrong. Application software loaded application. Right. So this is the best answer. Right. Third answer is the best answer. Through the system software support data communication between peripheral devices. Right. So hardware. That means hardware can be addressed by using the system software like operating systems. Then we'll go to 36. Which of the following correctly list the given computer storage components descending in the descending order of access speed. So highest access speed should come first. So that should be registered. That is fourth answer should come. 36. Fourth answer. I think most of you have put the correct answer. We go to 37. Okay, the following computer memory: CMOS, cache, hard disk, flash, RAM, register. Which of the one volatile? Volatile. This type of same type of question came earlier also. CMOS memory. CMOS memory you can't take because inside the CMOS I told you that earlier that BIOS programs are kept. So BIOS programs තියෙනවා කියන්නේ computer boot up වෙන්න ඕනේ ඒවා තියෙනවා ඒ නිසා එක ගන්න බෑ. Cache memory you can take. B ගන්න පුළුවන් flash ගන්න බෑ. RAM ගන්න පුළුවන් register. So fourth answer should come. 37 fourth answer. Most of you have put the correct answer. Okay, we'll go to the next one. Thirty-eight, 39, and 40. Who invented analytical engine? Analytical engine done by the Charles Babbage. Second answer should come. 38 one. Most of you have put the correct answer. 39. Which of the following statements is true about the computer developed during the past? True one. So fourth answer should come. That is theory. Directly you can put the correct answer. Then 40th. What are the basic components of a computer system? So basic components you have to have input, output, processing, and the storage. Third one should be the answer. Third one should be the answer. So keyboard monitor, those stuff are the example for that. But the components, input, output, processing unit, and storage. That's all for the MCQs. We'll go through a set of questions quickly. Try to put short and sweet answers. I'll give some time, 5 minutes. I'll discuss. State the main technologies used in fourth generation computers. You can write first generation vacuum tubes, second generation transistors, third generation integrated circuit, that is ICs, fourth generation microprocessors, so large scale integration. Fifth generation, even you can take ultra large even, ULSI. Draw the diagram to depict the fetch execute cycle. So you can write fetch, it is fetch, then you get decode, then execute. That's like a cycle. Execute. Again, it's coming, begin. Fetch decode, execute. Computer storage device can be categorized into 3 types based on the medium used. Store retrieve data. Still 3 types of media. So here you can write magnetic media. Put some example: hard disk, floppy disk, magnetic media. Then you can put optical media. Optical media. Put example: CDs, DVDs, and Blu-rays. Even you can take. Then solid state. Solid state. Memory card, pen drives you can take. Then we'll go to the part D. What are the 3 main components of central processing unit? Central processing you have list the main function of it. So you can write that you have ALU, we call arithmetic and logic unit, ALU. So in front of that you can write perform mathematical calculation and comparison operators. Perform mathematical and comparison operators for calculations. Perform mathematical calculations and perform comparison of data. Comparison of data. Then you can put control unit, CU. Decode instruction and controlling the computer or controlling the components. Then you have registers. Here write down temporary store data, and instruction, which is going and coming from the ALU, Go to next one. And embedded system 16-bit wide range. This is the the question which I did on the board previously. We got 64 kilobyte. That is the question we did. So I think you can manage that question. We have done that. So the next one. What is parallel computing? That's a theory one. Read the answers. You can write or you can refer the tutor if you can't remember. Parallel computing means what? Parallel computing is a type of computation in which many programs or processes are done simultaneously. Many programs or processes are done simultaneously. Large problems can often be divided into large problems can often be divided into small ones. Large problems can often be divided into smaller ones, which can then be solved at the same time. Which can then be solved at the same time. Then what is grid computing? There is also theory. You can refer that to it. I'll read the answer. Grid computing is distributed architecture of large number of computers connected to solve a complex problem. Connected to solve a complex problem. Connected to solve a complex problem. Right? So next one, draw the hierarchy of the memory hierarchy. You can, I think you can remember this kind of thing like this. We have separated this stuff. You can refer the tube if you can't remember. You have to put like this. So at the top you have to put the register memory. Register. Here cache. Here main memory. Here magnetic disk. Last you can put magnetic tapes. So other than that, the diagram which is in the tube bit different, but bit descriptive. Product description වැඩි එක අඳින්න. That's also correct. Right? Okay, I think you can understand now. This is the question which I did earlier. This is the answer that I didn't discuss that part. So that's all for the unit 2, right? Now you can understand this unit 2. You have to buy heart. Most of the thing you have to buy heart and answer, but you can't neglect them. අතල්ලා දාන්න බෑ. You are getting at least several marks. ලකුණු දෙකක් තුනක් හරි make unit එකෙන් එනවා. So you can't neglect, right? So next week we are going to start new lesson, that is unit 3. Unit 3 lesson, that is number system. Big difficult parts also there, right? So you have to practice from the beginning. So I will be sending a worksheet, that is a worksheet cute related to unit 3, right? And theory I am discussing in the board, and you have to write them in your books, right? But I will be sending the worksheet related to that unit 3, so you have to take printouts and get ready for that. So I will put it to the our WhatsApp group, right? So till next week, we'll finish for the day. Thank you.